this educational video on the action of penicillin. In this video we are going to explain how penicillin works by disrupting the biosynthesis of the bacterial cell wall. Penicillin was discovered in 1928 by Sir Alexander Fleming. It represented a revolutionary step in the medicine and pharmaceutical industries. As well as being the first widely prescribed antibiotic used to treat bacterial infections in humans, it also led to the development of many other antibiotics. Penicillin has been and is still used to treat many infections including Staphylococcus aureus, E. coli and syphilis. In order to explain the bactericidal action of penicillin, first, the biosynthesis of the bacterial cell wall has to be illustrated.
The bacterial cell wall is made up of layers of peptidoglycans. The cytoplasmic steps of peptidoglycan biosynthesis begins with uridine diphosphate N-acetylglucosamine, or UDP-GLC-NAC. This is catalyzed by enol pyruvyl transferase MURA, followed by flavin-dependent reductase MURB. This forms uridine diphosphate N-acetylmuramic acid, or UDP-MUR-NAC. The UDP-MUR-NAC is then further catalyzed by the ATP-dependent ligases MURC, MURD, MURE, and MURF, which add L-alanine D-glutamic acid, L-lysine, and a previously catalyzed D-alanine dipeptide. This forms a UDP-MUR-NAC pentapeptide.
The UDP-MUR-NAC pentapeptide is then converted into two lipid intermediates 1 and 2. This is catalyzed by translocase MRAY enzymes and glucosyltransferase MRAG. The MRAG binds the UDP-MUR-NAC molecule to a UDP-GLC-NAC molecule. The MUR-NAC is now bonded to the cell membrane.
In some gram-positive bacteria, additional amino acids are sometimes catalyzed onto the L-lysine using ligases, forming a lipid-2 intermediate. In the case of this strain of E. coli, it's an NH2-amine. This allows the pentapeptides to participate in the cross-linking in the peptidoglycan. The lipid-2 is then flipped across the membrane by flippase proteins.
Transglycosylase enzymes then form a saccharide backbone by catalyzing the formation of bonds between the saccharides of the lipid-2 molecules. During the cross-linking of the amino acids in E. coli, the transpeptidase proteins catalyze the formation of a bond between the NH2-amine group and the 4th D-alanine in the pentapeptide chain. The 5th D-alanine peptide is cleaved off. Between 40 and 60% of the pentapeptide chains in the cell wall are cross-linked. The glycan strands in the peptidoglycan have been shown to be rigid, while the pentapeptide chains are more flexible. The peptidoglycan structure has been shown not to be crystalline. This flexibility in the pentapeptide chain allows the peptidoglycan to stretch and compress.
The active site of the bacterial cell wall is shown here. The penicillin irreversibly binds to the serine residue in the active site, inhibiting the activity of the enzyme. The peptidoglycan layer constantly degenerates and regenerates itself. While the penicillin acts on the transpeptidase enzyme, the cross-linking of the peptides is inhibited, reducing the structural integrity of the peptidoglycan layer, eventually leading to cell lysis. Thank you very much for listening to this video, and we hope it's been an educational experience.